Hi there, welcome to this Matlab tutorial. I will be using Octave, but it's very similar to Matlab. Octave is free, Matlab you have to pay for it. But I mean the interface and all the commands and the functions you can use for basic operations are exactly the same between those two languages. So, first time when you launch Matlab, you end up with an interface like this, roughly. So this is Octave, but Matlab interface is very similar. On the top here you have the current folder where you will be working. This is an explorer of the current folder. So by default under Linux this is my home folder, but you can change that. So we'll see that later. This window is showing the variable you are using. So it's a calculation software, scientific software, so you will soon have some variables like temperature and so on. So all of this will appear here. This is the history of commands. So all the basically commands you are asking running under Matlab, it will be reported here. This is the main command window. So this is where you can put some calculation, very basic operation, let's say 1 plus 2. So of course you get 3. And something interesting is that here in the variable window you have a variable that has appeared, which is ans for answer, and it's already in double precision, so that's very handy. You don't have to specify. You can specify the precision, but it's very quickly. You have a variable that is in double precision. So you have the dimension. So why do we get the dimension? Because you will see we will be working with array, matrices. Matlab is for matrices. And it's much faster to play with arrays in many situations, to play with vectors or arrays of numbers and to apply operations directly on the entire array than using loops or table, where in that case you have to write a loop and change element by element. We will see an example of this. Okay, so of course you can add, you can specify the name of your variable. Let's say a is 1 plus 2 or plus 3, and then I have the variable a that is seen right there. Other windows that are interesting, you have here the help window or documentation window. Here you can look for functions and so on. Okay, this is the editing window. This is where we will write our first script. A script is basically a series of commands, for example 1 plus 2 and so on, b equals 5 plus 6, and then we can run this script so that all the commands are executed by Matlab. Okay, we'll see that later. And this window is a window that is used when you want a closer look to the variable here. Let's say I double click here on A, and I have kind of an Excel file showing me all the values of A. Of course, A is a single value here, so you just have one field case, but you will see that we have more numbers when we will be playing with arrays. So let's come back to the command window. Of course, we can specify several variables, let's say A and B, and then you can, of course, add those variables. A plus B is 11, and so on. You see that in the command window we have the result all the time. If at some point you don't want to see the result, you can just add this comma dot here at the end, and then let's say, for example, I want C equals A plus B, but I don't want to see in the terminal or in the command window, I don't want to see the result. Okay, then you don't have any result. Of course, the result is there. I mean, the variable C is created, and if you look at variable C, it has the value of 11, so it's correct, but it's not shown in the command window. That is useful because you'll see that in future scripts you will have many commands, and so you don't want the command window to show everything all the time, because it takes time and it reduces the speed of execution. Okay, so you can play with numbers. You can use, of course, I don't know, sign functions or several functions, then you have the results. You have many mathematical functions that are available. You can put exponential, multiplication, division, and so on. Something very practical is to use the up arrow on your keyboard. So the up arrow on your keyboard, yeah, right there, up arrow, that put back the last command you used, just like Linux terminal. And if you hit several times up arrow, you have all the command before, and then you can execute or not by hitting entry. But it's cool because sometimes we made a mistake, so we want to add, okay, that was 2 times b, for example, so I correct it and then I execute and so on, you see. So that's very handy. Of course, it's not just a calculation software like this, it's much better to use script. So let's go to the script editing window here, and there let's start to work on our first script, okay? Before that, something very important to know is this command clear all. If you use clear all, that will clear the memory, okay? And so you see here in the workspace, I don't have any variable, okay? So I clear all. Another one that is very interesting is close all. That close all the windows, additional windows that are open. For example, you will see that we will be plotting stuff, we will do some graphs, and we want to close them because each time we run the script, we don't want a new graph to be added because otherwise you have many windows all over. It's a bit complicated. So clear all and close all are 2 commands that are very interesting to use in our script. Usually the best thing is to start the script with those commands, okay? Okay, and that way each time we run the script, it will clean everything. Now, if we want to run the script, we just have to click there, or you can also hit the F5 button on your keyboard, okay, F5. And okay, let's do it. If I do it, there will be a problem because I didn't recorded my script yet. So Matlab wants me to give a name to this file. So let's run, and you see it says first you have to save it somewhere. So just find a place, and I suggest to create a folder that you will call Matlab Tutorial, for example, or Matlab First Steps with Matlab, okay? And then you call your script as you want, my first script, for example. .m, the Matlab file, or .m file, as well as Octave files, okay? So if I do that, you see that I changed, so my script is not recorded in this folder, in this current folder, okay? It's recorded elsewhere. So Matlab is asking me, do you want to add this folder to my workspace, or do you want to go to this folder? So I suggest you to go to the correct folder, and then you have one folder with what's inside displayed here, and then you know what you are working on, okay? Soon you will have some images there to work with. You will have different scripts, maybe functions, so it's better to have a clear view where you're working. Okay, so let's execute this. And you see that nothing happens. Indeed, Matlab is performing the stuff. We see here the variable appearing, but we don't see the results. The results are in the command window, okay? You see b is 11, just as I wanted here. 5 plus 6. So the best thing to me is to have always the command window not too far. So, and for that you can just pop out here, you can pop out this window, and then you have it here under your eye, so that you see what's going on and you see the results of what you're doing, okay? So you can of course leave some space like this, and then every time you execute, you see what's going on. And it's very important to do that because MATLAB is very good. It indicates you where you make a mistake. For example, let's say I want, okay, let's say I have those two variables, a equals 1 plus 2, b equals 5 plus 6. But let's say I wanted to write 5 plus 6 time a, but I forgot to put the time. That happens, you know, little problem. So let's execute that, and MATLAB is saying, okay, there's an error, and not only there's an error, but it's indicating you where it is. It's near line 4 of my file, blah blah blah, myfirstscript.end. So it's really indicating you where the problem is. And there is even some time, and we're lucky, an indication on which where it is exactly. So that's very important to have a look at what's going on. I mean, many times during the classes, it's not working, and the student is not even looking at the command window. Usually, the answer is there. Okay, so let's put back times here, and then it's working. Okay. So now let's work with arrays a bit. So an array, let's start with a very simple array using those straight brackets here. So it's not these brackets, it's those straight brackets. And here you can put several values. And if you execute that, you see that A is an array of 3 elements in line, one line of 3 elements. If I look here, double click here on the variable, you see that we have those 3 elements in an array. Okay, so coming back to the script, I can also have several lines of my array. Okay, like this, and then I have an array with 2 lines and 3 columns. Okay, you see. Of course, if I make a mistake and let's say I have too many elements at the bottom, so here I have 3 elements on the top, 4 on the bottom, it will not work. Okay, invalid call to script, you know, it's not working. Okay, so you have to pay attention to generate correct arrays. So okay, so there are several things you can do with this, and I will show you why it is important. Let's say, for example, you want to display the sine function. So the sine function or the exponential function. So we can generate one line, one vector of elements, and then b is simply exponential of a. Okay, let's do this. So we have the values of a right there, 1, 2, 3, 4, 5, 6, and here we have the exponential. We can vary. So you see, I didn't have to write a loop function that would go to calculate the exponential for each element. I could just apply this function to the entire array. I can also, of course, apply basic operations directly to the array, like, I don't know, 5 plus a. Okay. So I have a, b, and then I have c, which is 5 plus a. So it's that's why it's very handy. In science, many times you have some functions of temperature, displacement, or whatever, or images, and sometimes you want to just add one constant or multiply the image or the function with another one, and that way you can do it directly without thinking too much on for loops or while loops. Okay. So yeah, basically an image, we'll be working with images. An image is a 2-dimensional array. Okay, with so a numerical image is simply an Excel file with different values of light intensity. If we talk about grayscale images, okay. So of course, all of this can be applied to images if you once you load your images inside MATLAB, but you will see that later. Okay. So let's display a bit. Let's plot those values. Let's say I want to see what A looks like, so I can just use the function plot A. You see, and if you do that, you will end up with this window, and here you have a plot, a graph of the A function, 1, 2, 3, 4, 5, 6. Okay. You can, of course, plot the exponential of A, right? Okay, so I can just plot B. Now I can start to add those dot comma at the end, because I don't want the command window to be saturated with stuff. Okay, then I have B coming here. Okay, and I see an exponential growth. Okay, a command that is very important too is help. If you have a question about any function, for example the sine function, you just dial help sin, and then you have all the details concerning the sin function. You see, compute the sine function for each element of x in radians. Okay, right? And you can do help for any function of Matlab. Help plot. You see plot. There are many options in plot. So, for example, you can add here. You can change the color to red, like this. You can also add some points to the graph, like this. And so on. Okay. All right. Okay. So two things to finish. So there are functions that are really handy to generate larger arrays. Line space, not line solve, line space, is a function that allows you to create a vector, a one-dimensional array of values within a range. For example, I want values between 0 and 10, and I want 100 elements inside my vector. Okay, so if I do that, you see here that A is created. It has 100 elements. You can double click here, you see. So you have all those elements right there. Okay. And B as well as 100 elements. It's exponential of A. And of course you have the plot here. Okay. You can add title to the plot. You can change the X label, the X-axis label, and Y-axis label. You have many options, but this is you can find by yourself. It's not complicated. And another thing I'd like to show you is that of course you can use for loops with Matlab. Let's say instead of using this very handy way to obtain the exponential of each element of A, I can of course do it with a for loop. Okay, so I can start a for loop, and then I have to use this increment. So E equals 1 to 100. Okay, so yeah, you can use for loops, and let's compute the exponential of A, which is a vector. So I have to have this variable to go through each of the element of A. So it goes from 1 to 100 because this is the number of elements here. Okay, and then I will generate, so you see automatically you have for and end. This is how you write it. The spacing here is not important. It's not as in Python. It's not mandatory to have a spacing here, but okay, it's clearer, of course. So let's say I want exponential of A of each element of this vector. Okay, and I want to put that in a new variable, which would be c, and of course it's also a vector, so I have to first initialize c, which c is, it can be initialized by it could be a. I like to do it like this. I do a times zeros, so that way c is just a filled with zeros, and then after that I fill c with the exponential of a for each element. Okay, and so we will plot and compare the plots to see if it's equivalent, but there's no question, it should be working. So we will be plotting this time c, okay, and then maybe we can do it in blue this time, okay, and yeah, blue and with the little points here. The problem is that if we do that, the plot of C will override the plot of B. So we want the plot to be opened in another figure. It's another window, okay? So I will have one figure. The first figure will contain the plot of B. So I can add a title maybe to be sure I don't mix up. So the title will be B, okay? That's B. And then for C, up, title will be C, and then I can compare both. Okay, so let's try. So now I have two figures. So the second one is C, and the first one is B in red, and we see that it is equivalent. Of course, we can subtract one or the other, but one thing is that you see, to use the array the array formalisms is much quicker. It takes less sentences, and there's another thing is that MATLAB is optimized for that. For MATLAB, it's much quicker to do this than to do this. Okay, let's there is a command for that is quite fun. Is TikTok. So TikTok just look at the computer time and shows the time between tick and tock. So that way you have the time for the computer to perform this. Okay, and we can do also it for the second one, and we see which one is faster. Okay, so I'm just tick and tock. Okay, and you see that one is much faster than the other. Okay. So here, the first one, the first tick-tock here, using the MATLAB command, it lasts 2 exponential minus 5 seconds. So it's not, it's 1/100th of 1 millisecond. So it's very quick. If you use the 4 formalisms, then it's 100 times slower, almost 100 times slower if you use for loops. So each time you can use the arrays with direct operations on the array, it is much quicker on MATLAB. Okay, so hope you have fun with MATLAB. Make sure to practice all of this on your side, and there's a great community around MATLAB on the internet, so you can find many answers to your questions.